Good day, everyone. I will be discussing the Regula Falsi and Simpson wanted rule to be implemented using the Mathworks Matlab software. So first, let's discuss what is the Regula Falsi method. Regula Falsi method, or the method of false position, is a numerical method for solving an equation in one unknown. So it is quite similar to bisection method algorithm and is one of the oldest approaches. It was developed because the bisection method converges at a fairly slow speed. In simple terms, the method is a trial and error technique of using test false values for the variable and then adjusting the test values according to the outcome. So what are the steps to solve the problem using this method? So the steps to solve the problem using our regular parser method. First, if there is no initial value to be used given, we must find the values of x, which are xp and xn. Whereas xp would result in a positive value if we apply to the uh, f or our variables, and xn would result in a negative value if we apply to the variable. So which means if we apply the value of xp to the variable, it would result to positive, and if we apply the value of xn to the variable, it will be negative. Then what if the value is given? So we will use that directly, the values that is given. We don't need anymore to find what is the xp and xn. So third, uh, we will compute x new using the iterative formula. So first, we identify the xp xn, then we will compute for the x new using the iterative formula for the regular parity method, which is x new is equals to xp minus fxp multiply xp minus xn over xp minus fxn. So if we see this xp, so this is the value of x, that if we apply to xp, this will be positive. So xp, and our xn, this is the value that if we apply to fxn, this will result to negative. So value, so this should be positive, and this should be value, positive, then negative. So I'm saying that this is just a value, and we cannot say it because xn might be uh, can be positive or negative depending on the variable or equation that we have. Next, depending on the sign of fx new, assign the x new to either xn or xp. So for our next iteration, uh, we can determine uh, what value we will be using for the xn and xp depending on the sign of the fx new for our current iteration. So if our current iteration, the value of fx new is positive, so our x new will become xp, or we will use the x new as xp on the next iteration. Then the value of xn that we use currently, uh, it is still the value that we will be using on the next iteration, so we will retain it. So otherwise, if the fx new is negative, so we'll assign fx new to xn. So I mean, we'll assign the x new. So this is hyper error. So x new, should be x new. We'll assign this to xn. Then we will retain the xp for our next iteration. Next, and our last step, this is should be 5. So continue doing the process until we reach the following condition. So the value is 0. This means the exact value for the unknown we have been produced. So we have the exact value for the unknown. Or if the previous value of x new is the same, the current compute value of x new, and our tolerance satisfied. So if the previous one is equals to current one, is just say that the our next iteration will be the same. So we can use that value as the unknown. We have find the unknown through that value. Next, what we'll be using, so the software that we'll be using is Matlab. Matlab is from Mathworks, so it is a programming platform designed specifically for engineers and scientists to analyze and design systems and products and transform our world. The heart of Matlab is Matlab language, a matrix-based language allowing the most natural expression of computational mathematics. So this is aligned with other software programming platform such as Python, C++, and others. And this is just more inclined with this engineers and scientists. Also, for me, it is easier to do and as well as navigate than others. What can we do in MATLAB? So first, we can analyze data. Also, we can develop algorithms as well as create models and applications. So this is what we can do in MATLAB. And MATLAB lets us take our ideas from research to production by deploying to enterprise application and embedded devices, as well as integrating with Simulink and model space design. So next, we'll be discussing the code that I have prepared. So scope and delimitation of code. First, initial values of x and xp must be given. So if the xp and xn is not given, we can't use it. So that's the delimitation. Next, checking whether the x and xp is right. Next, we'll only show the direct root or value. So which means it will not show the number at the iteration before it come up with the unknown as well as the new values of xn, xp, fxn, fxp along the way as it's finding the unknown. So again, it will directly find the root value or the unknown value that we are looking for. Simple terms, wala nang. So next, code. So this is our code. So simx, it is setting us the x as variable. So f input enter function means if we run the program, uh, it will show that we must enter the function of fx. So for example, our variable is x4 plus 10x cubed minus 4021 x squared plus 56 800 x plus 29200. So we will enter that using at x. This just denotes that this is for the value of fx. Next, after we enter this, uh, the enter xn will prompt what it will show. So we will input the value of xn. So 47, for example, for this equation or function, and xp. After we input the value of 47, we will enter it. Then the enter xp will show. So 48 will show. Tolerance. So what we'll be using is 1 raised to negative 10. Doesn't matter, but specifically we'll be using a 0.01 or whatever you want to use. Error absolute value for the checker of tolerance. And this is our formula for the Regula Falsi method for the iterative formula, I mean. So this is checking for uh, uh, if we have not input the right x and xp, so this should be displayed valid, enter valid x and xp. So this is for the iteration. So while means the function is to let the command loops repeat the program. If the expression is true, then the new function can be input after the result of the previous one. So here comes the program, the iteration program. So if error is greater than t, so our x new will be computed and that will be a root. And if fxp, fx new greater than 0, so xp, x new positive. So xn, x new negative. So, and we will end it. So here and checker and this end for the while. And then we input the fprintf for the system or the code to print the value of the root or the unknown that we are looking for. So if we observe this 4.10f, This means that it will provide up to 10 decimals. So going to the code. So first, if we open the Matlab, so it will show. Then we can do a new. Then after the new, or here, we can add one. Then we can code that. So team X, F input, here we can load here. If we don't, if our code is not right, uh, it will show that there are things that we need to fix here. So there's a guide. So if we run this, at the command window, we can see that the enter the function fx, and we will input it. So as we have discussed, we will go with at x, and then our value is export less than x cubed. So x raised to 4 plus 10 x cubed, and then minus 40 21 x squared minus 40 21 x squared plus 56 800 x plus 56 800 x plus 292,000 plus 292,000. So here we can see that this is invalid expression, since we must take note that whenever we are doing a multiply, we must do a symbol for the multiplication. So we can go with multiplication sign, 4021 times x and 5680 times x. Okay, so our functions right now. So our xn is 47, our xp is 48. Our tolerance, we can go with 0.01. So directly our root is 470179226631. So I have here a sample. So this is using the Excel. So same function and then same value x and xp. And yes, we got the right answer. So 47.0179, 47.0179, 2266, 226631. So our root is right. So going back to our slides, this time we will be discussing the Simpson Wonder tool. So first, what is the Simpson rule? Simpson's rule is a method for numerical integration. In other words, it's a numerical approximation of definite integrals. So Simpson rule is one of the numerical methods which is used to evaluate the definite integral. So usually to find the definite integral, we use the fundamental theorem of calculus, where we have to apply the antiderivative techniques of integration. So, however, sometimes it isn't easy to find the antiderivative of an integral, like the scientific experiments, where the function has to be determined for the observed readings. Therefore, numerical methods are used to approximate the integral in such condition. So, so this is the Simpson one-third tool. So we have a minimum of 3 points. So from A to B, then uh, the interval between them, or the segment between them. So as shown in the diagram, the integrand fx, so that is our integrand, is approximated by a second order polynomial, the quadratic interpolation being px. So the approximation follows integrate of a to b fx dx, approximately it is equals to b minus a over 6 uh, open close parenthesis f of a plus 4f and open close parenthesis of a plus b over 2 plus f b. So replacing b over b minus a over 2 as h. So we replace this as h and this is as h. So h over 3 open close parenthesis f of a plus 4f a plus b over 2 plus f of b. So seeing this, this expression shows that why this is called one third rule. So Simpson one third rule. So this is the third rule. I mean, it has a one third due to the expression factor one third. So this why this is called the Simpson one third rule. So in order to integrate any function fx in the interval a b, the following steps given below. So select a value of n. So we must select then which is the number of parts the interval is divided to. This means our segments. How many segments we will be divided this and calculate the width, so the height of, or this is the uh, difference between the segments, the height, b minus a over n over the segments. So, for example, our a is equals to 1 and b is 2. So, 2 minus 1 and our segment for the minimum is 2. Therefore, 2 minus 1 and 1 over 2 is equals to 0.5. So our segments will be 0, 0. Hey, again, our segments will be first is the 1, then 1 plus h equals to 1.5, then we'll go with 2. So calculate the values of xo plus xn as xo is equals to a, x1, xo, and consider the y is equals to fx. So we'll be finding the value of y, yo, corresponding to xx. So then we will substitute this to calculate the Simpson using the Simpson formula. Then approximate integral can be given by the Simpson rule. So next, for the Simpson one-third rule, as we said earlier, we need at least two segments to implement the rule. For two segments, you need 3 points. So 3 points. So segment 1, segment 2. Segment 1, segment 2, 3 points. Again, now as we discussed earlier, our points, for example, our A is equals to 1, our B is equals to 2, our the M is equals to 1.5 due to the height. So height is equals to B minus A over 2. So A plus height is equals to M. So M is equals to 1 plus 0.5 equals to 1.5. Implementation with the minimum number of points. So if we're going to integrate a number of fx with limits from a to b, implementing Simpson's one-third rule with at least number of points, you need to determine the 3 points. So x0, x0, x1, x2. For you to know those points, you need to compute the interval h between points. The formula for h is, as we said earlier, this same before, h is equals to b minus a per point, last point, minus the first point, over number of segments. For example, over 2. For this, 3 points will have value of x0, a, x1 is equals to a plus h, the height, and x2 is equals to b. For the implementation with multiple number points, if you have the implement, it will multiply. The only difference is just the number of segments. So if we have multiple points, then multiple number of segments, our height or interval with between points will be much smaller. So one important rule for Simpson one-third, the number sign must be multiplied by 2. So it must be multiplied by 2 since we will discuss later why is it should be multiplied by 2. They are not multiplied by 2, you can implement it. Your points now will be x0 is equals to a, x1 is equals to x of h, x2 is s1 plus h, up to xn is equals to xb. Up to the time that uh, your value of x will become the last value, as we said, depending on the given. So b. In order to integrate function interval a, b, follow the steps given below. So using one-third tool, so we will discuss y must be multiplied by 2. So the segment must be multiplied by 2 since it need at least two segments to implement. The succeeding values will reuse the already used segments. So if we use the segment for the next, it will reuse. So it must be only multiple by 2. So any add value will be for the first three. If you have minimum for the add value, we cannot compute or we cannot choose this. For the following, if more than the minimum required points, the values for the add will be cancelled out, or it will be zero. Should should be act as zero. So the value will be summation of x2, x4, x6, x even. So if you refer to this, xo, x1 will be 0 since the minimum is 3. So we will start with the x2. Then x3 is 0 since it is odd. And x4, we have the value of x4. Then we will add the x2. And x5, 0, x6, we will have value. So we add x6, x4, x2. And uh, for the continuation, our odd values will be act as 0. So we will only add those even values. So the more segments you use, the more accurate the value is. So as our segments or as our height, as we have a larger or more number of segments, our value will be more accurate. So again, for this, we will be using again the Matlab. So Matlab, as I said earlier, we can do with Matlab analyze, we can develop algorithms, create models, and yeah, no, we can do these things. So these are example. So simx for setting as variable, for input f, setting f input for the function. For example, we will input the sin x plus e x, so exponential x. So a for the input for the lower limit integrand. So for the a, for our a, if we look back, so this is our lower limit and this is upper limit integrand. So from 0 to a. Our lower is the a and our upper is the b. So for example, our a is 2.5, our b is 1.5, and enter the number of segments. For example, we do have a number of segments of 2. Since we do have a number of segments of 2, our h will be 1.5 minus 0.25. So we do have 1.25. Then over 2, for us to compute the value of h, 1.25 over 2 is 0.625. Then for us to compute the value of m, which is in the middle, or our x1, 0.25 plus 0.625, we do have 0.825. So that's next. This for the uh, formula to find our h. So find different value per segment, difference between the segments. So our step 0. For this, we are setting zero matrix, which that all the elements are 0. People use zero matrix in different mathematical and calculate setting 0 values for the odd. So we are setting for the odd values 0. So for the I, for the mod, with this returns the remainder after division by 2. Where is the divided? Where is dividend and 2 is the divisor. For the C0, we're starting with this 2. Then we will try 12. For this step, raise to n greater than n. So this change in input from 0 to infinite value of time. So this is as we are continuing depending on the segments. So for example, 0.25, 0.825, then 0.825 to 1.5. For k is equals to 1 and 1 for the minimum segments is this for determining value per segment. T is equals to a, so we are setting the t is equals to a plus step. So from our step, multiply by h, determining the value per segment. So our step. Then setting 0 since Simpson is at least two segments, so we are setting this as 0. For this equation, we are for the minimum, for more than minimum segments, so this is our equation. Then we will summation of even value, it will sum, then we apply the Simpson to underdo equation using this. And for the f printf, the integral is 410, same as before for the Regula Falsi. So up to 10 decimal shows the unknown. This shows the unknown. So going to the Matlab, here I already tried this. Let me clear this first. So as we input, so first, as I said earlier, we'll go with the opening Matlab, then we will open if we do have a one or a new one. Or if you have an open a folder, we can add here for additional one, two for our working file. Yeah. So again, this is what we have discussed in the slide, and we can, and after we accomplish this, we will go with the run for us to run our code. So sample at x multiply for our x function is sine x plus exponential of x. Our lower limit integrand, for example, is, so we do have an Excel for this, is 0.25 for lower for a, and for our binomial value is 1.5, 0.25, and upper limit is 1.5, or our letter B. Number of intervals, we can go with the minimum. So the integral is 4.099266794. 4.099226794. Again, as I said earlier, this code will not show the steps on per steps. It will only show the final value that we will be determining using this. So the unknown value. So it directly shows the unknown value. It do not shows the f of x along the way. It shows the final value, which is our main goal. So 4.099267954. 4.099267954. Again, we can try for the 12 segments. So times 12 segments. Here is sample of 12 segments. Same function for same given, but our segments will be 12. So from 0.25 to 1.5, and our intervals will be 12. So 4.095841550. 4.0958411. 4.09584115508. 4.09584155008. So if we want a more decimals, we can go with 15 by making this as 15. So again, so we can check uh this. We can go with a shift C for us to stop if ever there is calculating, and then we can run, and we again input our function, and our lower is 25, 1.5, and again 12. So here you can see that it shows 15 decimals, so 0.9584 for the first 5, 9584, then 15508, 15508, 32720, 32720. So that shows that our code is correct. So that will be all. Thank you for uh, watching this video.